This is a quite typical questions about linear system inequality, and then that means this representing a few lines, and then bound a region that you can choose the feasible solution, and then under those feasible solution we have to find the least value. That means the combination of x and y to make this become minimum, and then whenever you have this type of question, it's really time consuming because you need to have a brief idea where are those nine. Maybe you need to find all the vertex, especially if you have four lines here. It's difficult for you to try many different vertex. You can't avoid using the sketching of the graph to find out the possible solution. So to do so, I always suggest my students change all the line in terms of slope-intercept form for easy sketching. The first one, x minus 21 smaller equal to 0, so x smaller than 21. The first criteria is x is less than 21, so this is 21, and then we are talking about left-hand side. Any x less than 21, any point with x larger than 21, we can't choose. We can only choose this region. And then after that, the second line, x minus y minus 35 smaller or equal to 0. That means y is larger than x minus 35. Y is larger than x minus 35. What's a good thing to rewrite in slope-intercept form is because we get the slope and the y-intercept directly. That means if this is negative 35, and then the slope is 1, so 45 degrees going up, and this is 35. This graph is not really on scale, so but anyway, y should be larger than that. Larger than, that means up. We are talking about upper part. Only the upper region we have greater height, y representing the highest position. So we are talking about this line. Now our feasible region. Our feasible region is this region. And then continue. The third line, x plus 5y minus 91 smaller or equal to 0. Again, we use similar reason. Negative x and then plus 91. So y is negative 1 over 5x and then plus 91 over 5. So if I draw this line, it's going down slowly with the y-intercept is slightly more than 18. So maybe it's like this, 91 over 5, and then go down slowly. And then this time we are talking about smaller than. Smaller than, that means lower. Lower than that. Downward. So now our feasible region is within this range. Because this line is effective, we can just choose some area lower than that. And then the last line now. 3x plus 2y larger or equal to 0, so y is larger than negative 3 over 2x. This one pass-through origin is because y-intercept is 0, and then the slope is going down. So going down, and the slope is negative 1.5. And then they say y is larger than that. So we are talking about this region. There is a bounded region. Our bounded region is this one. By 4 constraints, you'll find that the outline, 1 line, 2 line, 3 line, 4 line. Each line here represent 1 constraint here. So we can only choose some point xy combination within this range. All other points outside this range we can't choose. And then among this feasible choice, we are going to choose which point will make this one become minimum. If you calculate all the vertex, 1, 2, 3, 4, you have 4 vertex you can choose. But in MC, you don't have enough time, right? And if you look here, x is positive coefficient. Y, we have positive coefficient. That means less x and less y is our target. So compare with these 2 points. less x and less y is always better. So you won't choose this point. You won't choose this point. You won't choose this point. The only possible point is this point and this point. That's why you are going to find the vertex of this line and this line. If you remember which line we are talking about, this line is y equal to x minus 35. And then this line, this is the last one, y equal to negative 3 over 2x. So this point is talking about y is equal to negative 3 over 2x, and the intercept of y equal to negative 1 over 5x plus 91 over 5. You are going to solve this solution of these 2 points, and then you are going to substitute inside to see which one is the least value. And then after some calculation, we find that this line is x equal to 14 and y equal to negative 21. And then another point, this point is x equal to negative 14, y equal to 21. So we are going to test these 2 points and then see which one will give the least value. And then you'll find that the effect of y is more obvious. So we prefer less y compared with less x. So in this case, of course, we will choose this one. The minimum is 5 times 14 plus 6 times negative 21, and then plus 2, 3, 4. Then we get the answer is 178. But of course, if you think that it's not really sure, then you may try this point also. So for negative 14, 21, this point, 5 times negative 14 plus 6 times 21 plus 2, 3, 4. And you get 290, but this is not our target because it's not minimum. Our answer is 178, so the answer is C. Once again, this is quite troublesome, and then they try to give you more than 3 lines instead of just 3 lines. They don't want you to just simply use calculator to get all the vertex. So if you choose this vertex, then it's totally useless. You can't choose this vertex. So you can't avoid to sketch the graph very quickly, and then you find the relevant vertex, and then you substitute inside to get the answer.